Hello guys, welcome to the .NET interview deep dives. And today's question is, what is the stack versus heap memory? Whenever the interviewer asking about the performance based question, so definitely interview will ask you the first question as the stack, like what is the stack and what is the heap memory. Or in the previous videos of the .NET interviews, so when we discuss about the value types and the reference types variables, so at that moment we discuss like little few things about the stack versus heap memory, but we haven't discussed in a depth. So this is why I thought I should create the separate video on the stack and the heap. Or even I have asked the same question to the junior and the senior developers in the interviews, or they always failed to answer to reply these questions as well. So this is why I thought I should create video on this topic as well. So first we should know like what is the stack and the heap memory. So if so at that moment we discuss the things like whenever your data types is value type based, so definitely your values are stored in the stack memory. But whenever you create the object, like it can be your list, it can be your array, class, string, so all such things I would call or like all such things that is stored in the heap memory. Or the heap memory always store the reference of that variable. So these are some basic difference that we have discussed earlier in the previous videos. Now we have to discuss in depth as well. So there is a common thing that you that you feel sad like whenever we talk about the stack memory, so we always consider the value type data types. Okay. Or guys, I just want to know there is a struct data type, so I want to know is it the value, or is it the reference type data type. Okay, I have discussed this particular thing in that video. If you have watched this video, so definitely you will give the answer, or if you know the answer, just drop your answer in that comment box of this video as well. So there is a one common thing that whenever we talk about the value type data type, so we always focus on the stack memory. But whenever we goes with the reference variables or like reference data types, so we always talk about the heap memory. Or the value type memory, like value type data type has a fixed size. But if you talk about the array, list, dictionary, classes, strings, so there is no any specific limit of these things as well. Okay. So the first comparison that we have understand, like if anything is goes in the stack, it means it has a fixed size. But whenever the things goes in the heap, so it means like it is not a, like it has not a fixed size as well, like array, classes, or like it is not a like predefined sizes as well. So this is the first comparison that you will get to know about the size of your data types as well. Okay. Now, or like what is so first we will discuss about the stack memory. Okay, so let me write the points for you. Stack. Okay, so the first point regarding the stack is like when, so it is the functional calls, or it is known for the control flow. It means like it always works in the scope of the functions. First thing is that. Another is like whenever you create the local variables with the known size. Okay, so first let me write that like you will get to know that like you have known the size of that data type or the variable as well. Okay, functional calls and the control flow is also available in the stack memory. Whenever you work with the method parameters, so At that moment you will notice or every so at that moment everything is goes in the stack memory. Last point is like whenever you return the addresses, so it always goes with, so like a stack memory is also for the return addresses as well. So first you should know like how it works whenever the things between like whenever things in the stack memory. Okay, so how it works, first thing is you should know, so it follows the LIFO principle. So what is the LIFO principle? If anyone have studied the DSA in the BTech, BCA courses, so you are aware about the FIFO, LIFO terms as well. So last in, first out. That's which the thing which enters in the last, it will also get out first as well. So this is how the things behind the LIFO concept. Okay, or if you want to know what is a stack is kind of like a suppose there is a plates is arranged in the dinner. Okay, in a buffet, so you will get to know your waiter will put the plate one by one on the top. Okay, or and the guest will take the uppermost plate while having the dinner. Okay, and this plate was placed a very last time. Okay, or you are taking it a very first time. So this is how the stack behaves in the real world. Okay, so this is, I will call it as a LIFO phenomenon. Okay, or it has a very fast allocation. Okay, definitely guys, if your data type is known size, so definitely you will have a very fast allocation and you will get to know and you will allocate the size and allocate the memory very quickly. So this is why it has a very fast allocation. Now the next thing is like it all, so it is automatically managed by the compiler as well. Okay, so it is automatically managed by the compiler. Obviously guys, so also there are a lot of things you will get to know, or it has a many benefits of the stack memory. Okay, or it is also arranged and it is also managed by the compiler, and even I will call it as a runtime. Okay, even it also managed in the runtime environment. Okay, now whenever we talk about like memory is freed when the function is returned. Okay, suppose your function is in this block. Okay, so this is your function. So whenever the function is ends, so your memory will be free. That's it. Okay, so free memory, that's it. So this is the things behind the stack memory. Okay, or what are the key properties of the stack memory? Okay, so the benefits, so let's see about the benefits as well. So it always contains the short-lived data. It means like it means like like a GC0 uh, garbage collection. Okay, like it like which has the GC0 garbage collection. So the value type, the type always have the short-lived data as well. Okay, now the size is also limited. Yes guys, we have discussed the things like you will know the size of your data types as well. So size is limited. Along with that no fragmentation is also happens. Okay, like there is no any fragmentation is created, and it is not possible to divide these things into the other things as well. Okay, like there is no any partition is also available. Okay, so this is why we call it as a no fragmentation as well, or deterministic lifetime as well. Like we can assume the like how like what is the lifespan of this data type, okay, in the stack memory, because we all, because it is the short-lived data, or short-lived data is also has the known size, or it is depends on the function calls and the control flow, or it always works with the method parameters on or whenever you're trying to return the addresses. So at the moment you will see like your stack memory will work, or how it is work. It has the phenomenon of the LIFO concept. I have explained you what is the LIFO concept with the real life examples uh, in the form of dinner plates, okay. I hope you get to know about the stack memory. Now let's take an example of the stack memory as well. So suppose I will just create the function, okay. So void or example. So suppose my function name is example, okay. Somehow I am just gonna to define the size of. I'm just going to create a variable. You all know the fixed size of like what is the size of the integer variable. If you know the answer, just drop me in the comment box of this video. Definitely guys, I will give the shout out on this particular answer as well, okay. So you will see like this variable is stored in the stack memory, because we know the size of the integer. Along with that we know the like it has the short-lived data as well. The life of this variable is in the scope, okay, like it is a scope level lifetime, okay. Or you will see like whenever the function ends, so like this variable is not reachable anymore, okay. So this is why we call it as a short-lived data type, or like it fall like it like we can assume the we can determine the lifespan of the uh, this variable as well, okay. So this is how we talk about we have talked about the stack memory. I hope you get to know about the such things as well, okay. Or whenever the function ends, so your x will be gone, or no garbage collection is involved at this moment. First thing is that guys, okay, like it is not really focused on the garbage collections. We will talk about the garbage collections in the heap memory, okay. So now let's discuss about the heap memory as well. Guys, I just want to request that please take the screenshot of this screen so that you will have the screenshot in your mobile phone as well, okay. So simply I will just delete those content. Now it's time to discuss about the heap memory, okay. So so when the heap memory, so suppose you create an object with the unknown size, okay. So object with unknown, or even we can name it as a dynamic size, okay. So at this moment your heap memory will come into the role. Thereafter data that must outlive the function that created it, okay. So like this data is also accessible outside of the scope as well, okay. Or like the data shared across the functions and threads as well, okay. Like your data is shareable to the across the threads as well, okay. So if so all the point if I get to know like your like you have the shared uh, like in the heap memory, when whatever the things goes in the heap memory, so we can share the data, we can share the reference to each another. That's it. So this is the fundamental thing up behind the heap memory. Or now let's discuss now let's see that how it works, or it you should know this point as well, okay. So how it works. It works when you allocate the memory using the new keyword, like whenever you are gonna to create the new object, new list, new dictionary, and any kind of the new objects, okay. So in such a way your like everything is goes into the heap memory. Okay, it is slower than the stack memory because you are not like you are not aware of the size of your object. Even you don't know like your data is shared which variables as well. Okay, so I would tell like I would write it as a like a slower than stack memory. Okay, now it is time to like lifetime is not tied to the scope as well. In the previous example we see that we created the function, or in the function we created the variable integer x equals to 10. So we get to know like your like these such things is no like it is based on the scope level. Okay, whenever the function is complete, so it is not accessible anymore, but you can access these things which is stored in the heap memory is also accessible outside the function as well. Okay, so accessible outside the scope, that's it. Now, or can fragments over the time. It means that you can make partitions of your data which is stored in the heap memory, and this uh, phenomenon not works in the stack memory because the like it is the primitive data types. Okay, integer, boolean, decimal, or float. So such the data types I will call it as a primitive data types. Okay, or there is no any fragmentation is available. Okay, but whenever you talk about the classes, list, dictionary, so fragmentation is also available. Okay, like even the the fragmentation is also possible over the time as well. Okay, so this is how the things works behind the heap memory. Okay, if you want to see the key properties of heap memory. Okay, so the first key property that you will see here, okay, like it is the long lived, of course. Long lived is more than that. First thing is that. Okay, or much larger than the stack, of course. Like the class as class obviously have the uh, greater size than the stack variables. Okay, if along with that it requires the like it requires definitely it requires the garbage collections. Okay, in the stack memory I told you that we need the garbage collection, but it is not like it is need the garbage collection in the stack memory. Okay, like we in the garbage collection we have the three levels: 0, 1, 2. 0 means like very short lived. So I told you earlier in this video like the shorter lifespan is similar kind of the GC1. That's please keep this thing in your mind. Garbage collection is not required in the stack memory. Okay, but in terms of heap memory, of course we need the garbage collections as well. Okay, now you have got to know idea about like what is the difference between the stack memory and the heap memory, or how we can convert like how we can make the stack. Suppose I have the object and I am just wanted to create the object like this using the new keyword. So in such a way like we will need like so like your object is stored in the heap memory. Okay, so along with that like garbage collection manages the heap memory, not the stack memory. First thing is that. Okay, your stack memory has a clear lifetime. Your stack memory has a like a known lifetime as well. Along with that, if like heap memory doesn't not. This is why we need the concept of the garbage collections. Okay, because we are not aware of this thing like how like the variable is stored in the heap memory, how much it has the life. This is why the garbage collection has to run to clear and to freeze like free your memory as well, and to make this application in a very better way. So this is why we need the garbage collections in the C sharp. Okay, or I hope you get to know about the stack versus heap memory. Okay, in terms of performance, you have understand and you have the clarity between the stack memory and the heap memory as well. Okay, I hope you get to know between like terms between these two things as well. Okay, or if you know this, if you love this video, if you love this content, so guys, I just want to request you please subscribe to our YouTube channel and share this video to your friends or colleagues on it as well. Or guys, there is I just want to say sorry that like I couldn't speak properly because I have the throat infection. So this is why like, I am not able to talk properly. Okay, so please skip and please ignore the voice in this video as well. Okay, or I just want to request that please subscribe to our YouTube channel and share this video to friends or colleagues as well. Or so till then, take care, guys. Bye bye. Have a good day.